Right, we're on the air. Good evening. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre South. And a very pleasant good evening to everybody that's tuned in on 3541 kilohertz in the 80 meter amateur radio band, and streaming on YouTube and also by the Melbourne television repeater VK3RTV. Very pleasant good evening to everyone. It's listening to those various modes, and anybody that's up at the Leon Mao Dark Sky site that might be viewing on the big TV set in the club room, and send us a message if that's the case, either to text message if you've got my phone number or email address. We have an active email address, vk3ekh@gmail.com, vk3ekh@gmail.com, or via the chat window. We have a Discord, something called Discord chat window. Look for Astronomy Chat Room, it'll do. And we've got Stuart VK3AUIO there, and Martin VK7JAH down at Launceston, already tuned in there on the Discord. And I'm sure more will join on this 8th day of December, rapidly coming up to the end of 2000 what is it, 23. Yep. All right, yes, running just a couple of minutes late. My clock here is actually 2 minutes slow. It's what happens when you use battery powered clocks. But I was making a cup of coffee and I thought I had 5 minutes to play with, but suddenly realized I didn't. Anyways, all right. The Astronomical Society of Victoria, founded 1922, and comprises well over 1,600 members scattered about the countryside, Australia and overseas. Membership of the Society is open to anyone with an interest in astronomy, and the Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter is being held on a Saturday night. Meetings start right on the noggin at 8 p.m. and at the Mullier Hall, National Herbarium, Burwood Avenue, Melbourne, and aim to finish at 10 o'clock. With cups of coffee and tea and bickies. Meetings are also put out onto the ASV's YouTube channel and the Facebook channel too. They are now streamed, which is really good. Meetings start, I've already said that. Where are we? Parking is available in Burwood Avenue, Dallas Brooks Drive and surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at the Melbourne Observatory, receipt of the ASV magazine Crux, containing articles, news, observing, notes and the like, and the free provision of the Astronomical yearbook, which you can only really get if you become a member. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after the monthly meeting, depending on the weather. These instruments include the Society's 300mm Victoria reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible to members too. The Society also has a number of 200mm reflectors available for short period loan on the ASV telephone loan scheme. So you can try before you buy idea. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, which range from 300mm to 1000mm in aperture. And also located on the side is a fully steerable 8.5-metre radio telescope, a Kennedy dish, which members can access with involvement in the radio astronomy section. And a very pleasant good evening to any RES members that are up there right now as we speak. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook, and further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra Bulletins, which are sent out via email every other week to fill in the gap between the Crux magazine. Please note that ASV will conform to government health directives. ASV events may be required to be cancelled, moved or postponed. If you wish to write a letter to the ASV, address the envelope to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Otherwise, the ASV website at www.asv.org.au, and all will be revealed. So yes, there it is in a nutshell. And I believe this weekend is the Starbq. Just checking that on the homepage. Just making sure those dates are right. Is that it? Quick before it fades. Where's the date? 9th of December, which is tomorrow. Yep. So we have the regular ASV Starbq, the biggest Starbq, the biggest get together up there at the Dark Sky site. Hopefully the weather will be nice. It's going to be a bit of a wet weekend, but as we know, the weather on the other side of the Great Divide is always just that little bit different. So what turns out to be a cloudy and not so sure sort of day, by sunset it can clear up there pretty well and truly. Anyway, I wish everybody a good time up there. I'm sure they'll get probably easy 200 people up there, so I hope it's a good time. All right. Okay. Good evening to Steve, VK3 SPX, and Kim, VK5 FUSC over there in South Australia. Emails. Yes, we have an email from the Wayne Factor, and also Stephen as well. 80 meters is fine. Usual signal strength and audio lovely. No DATV tonight, however. YouTube video and audio is fine. Good. No DATV. Well, I'm transmitting through the repeater right now. I can see myself coming back. Maybe it's you're saying that you're not seeing it. It's okay. Heavens above, and it was. All right. We got halfway through the Sky Notes last week. In fact, I might just do a very quick summary of the Sky Notes from Tanya Hill, the resident astronomer at the planetarium Science Works. And let me see. She starts off by talking about the summer solstice coming up. Earth will have its solstices on Thursday the 22nd, summer solstice in the southern hemisphere and winter solstice in the northern hemisphere. So it's Thursday the 22nd. Won't worry about that. Melbourne sunrise times for Monday the 11th. Sunrise is at 5:51 a.m, setting at 8:35. Thursday the 21st December, sunrise at 5:54 a.m, setting at 8:41. And by the end of the month, Sunday the 31st, sunrise will be at 6 a.m, setting at 8:45 p.m, with the average day length being 14 hours and 44 minutes daytime wise, sunlight time wise. I think that's what it is. Moon phases. Third quarter is on the 5th, been and gone. There's a new moon on the 13th, Wednesday the 13th. There's a first quarter on Wednesday the 20th, and a full moon on the 27th, Wednesday. Tuesday the 7th, been and gone. I won't worry about that. Although, yeah, that was the moon distances. On the 7th, the moon was at apogee, furthest from the Earth, at 404,000 kilometres. Sunday the 17th is lunar perigee, closest to the Earth at 367,901 kilometres. And planets in a nutshell. Mercury is too near the Sun to be seen from Melbourne this month. Venus is bright as the morning star, rising in the east around 3:30 a.m. Before fading in the early dawn light. Mars has completed its pass behind the Sun, its solar conjunction, when it was co-joined with the Sun from our view on Earth. It is still too close to the Sun to be seen this month, but the red planet will reappear as a visible object next month. Jupiter continues as an easily seen planet from 9 p.m. in the north. It will move across the northern sky and set in the west by 2:30 a.m. So it's a good nighttime object at the moment. Saturn will be faint and yellowish. Can be seen for part of the night this month in due to the west from 9:30 p.m. before setting at 1 a.m. Meteors. The Geminids run from the 4th to the 17th, peaking on the night of the 13th, 14th of December, and appear in the constellation Gemini in the northeast. Most meteor showers result from Earth intersecting particles shed by comets, along with their orbits around the Sun. However, Geminids are connected with the asteroid Pantheon, I think that's how you pronounce that. In good viewing conditions, up to 120 meteors per hour can be seen, or could be seen. And do I worry about that? Stars and constellations. If we look to the east, summer offers a rich selection of features to enjoy from the northeast to the southeast. Some constellations used by astronomers appear upside down in the southern hemisphere. Travelling from one hemisphere to the other will change the orientation of the star pattern, and we all know that. As the viewing angle inverts, the star pattern, which will be the case of the moon as well. Sirius is the principal star in the constellation of Canis Major and sits directly east in our evening sky. To the left is Orion the Hunter, with 3 bright stars forming a line as his belt. In our southern upside view, his two shoulders are Bellatrix at the lower left and the red giant star Betelgeuse at the lower right. His 2 feet are marked by Regal, and upper left is Siph, upper right. I think that's how you pronounce that. Well known to many is the local asterism, the saucepan, and being the right way up, its base is Orion's belt, and its handle forms the hunter's sword. If we turn to the north, Taurus the bull can be seen by finding the red giant star Aldebaran, which marks its red eye, and is one corner of an inverted V which forms the bull's head. Very easy to see that, very noticeable. At 65 light years away, Aldebaran is closer to us than the other stars that are at 150 light years and form an open cluster known as Hades. To the left of Aldebaran is the beautiful Pleiades star cluster, or the Seven Sisters. Always beautiful to look through through a telescope or even a pair of binoculars. In many widely separated cultures, this open cluster often represents a group of women, sometimes connected to the figure of a man seen in Orion. If we turn to the west, in the southwest sits Sagittarius. Low in the west is Capricornus, the sea goat, and higher up is bright Fomalhaut. And of course, the principal star is Pisces Austrinus, or the southern fish. If you look towards the south, low in the south and upside down at this time of the year is the Crux, Southern Cross, with the pointers Alpha and Beta Centauri. To its right, guiding the eye to the Crux, our galaxy's 2 small neighbouring galaxies, the Large and Small Magellanic Clouds, sit high in the south. And for those who weren't aware, that there is some sort of discussion about changing the name of the Magellanic Clouds. I did discuss that a few Fridays ago. But whether that will actually happen is another story. Behind the Southern Cross and stretching from south to north is the beautiful Milky Way, which can really be only seen in its full glory from dark sky sites, away from city lights. But behind the Southern Cross and stretching from south to north is the Milky Way, dense arc of stars containing large interstellar dust clouds that block our visible light view from more distant stars. Famous among them is the coal sack that visits or sits beside the Southern Cross. And I can remember once upon a time being able to see the coal sack from Melbourne, from East Dandenong, where I was brought up, but not these days. And I've got vague memories of seeing the coal sack, but I know that one of the very first times that I went up to the dark sky site up at Heathcote, the coal sack is something very, very visible, and it's quite easy to see. Amazing. Okay. The International Space Station orbits every 90 minutes at an average distance of 400 kilometres above the ground. Tomorrow night, if the sky is clear, tomorrow night, Saturday the 9th, there is a passing of the International Space Station at 10:26 p.m. Might be something to look forward to, guys. So it's coming. Look towards the northwest, and so look towards northwest at 10:26. And the passing finishes at 10:33, so she shoots across the sky pretty quickly. But yeah, look out for that. The International Space Station will be passing tomorrow night, 10:26 p.m. to 10:33 p.m. northwest to southeast. And then on Sunday evening as well at 9:38 to 9:44 p.m. if anybody's still around looking up. On the morning and evening, Tuesday the 12th, there's a passing at 4:55 a.m. to 5:02, Tuesday the 12th, and a little later at 9:36 p.m. to 9:43 p.m. same day. Heavens Above is the place to go to if you want to find out more about passings for any satellite or any celestial object. Heavensabove.com is the place to go to, and don't forget to put in your latitude and longitude in to get more accurate locational information on things. All right, so let's kick off with some of the dates just to finish off, because I think I got up as far as Mariner 2, 4th of December 1962. I think, can't remember. Excuse me. On the 14th, 1962, Mariner 2 is the first probe to do a fly past Venus. On the 15th of December 1970, Mariner 7, USSR, is the first probe to land safely on another planet and to return data when it arrived at Venus. On the 21st of December 1988, cosmonauts Vladimir Titov and Musa Manarov make longest space flight, 365 days, 22 hours and 39 minutes on the Soviet space station Mir. Good old Mir. Also on the 21st of December to the 27th, 21 to 27th in 1968, was Apollo 8. First manned craft to orbit the moon, 10 orbits at 110 kilometers above the surface, imaging landing sites, and also had photographed the iconic Earthrise photo. On the 24th of December 1979, ESA's first launch vehicle, Ariane 1, France, orbits its first test satellite, CAT-1, CAT-1. On the 27th of December 1571, discoverer of laws of planetary motion, Johannes Kepler, is born. 1571, Johannes Kepler. On the 28th of December 1612, Neptune is observed for the first time, but mistaken as a star by Galileo. 1612. And by the end of the month, the 30th of December 1924, astronomer Edward Hubble announces faint nebulae. Nebulae are actually galaxies beyond our own in 1924. Okay, that's it. Thanks, Tanya Hill. If you're listening there, Tanya, good on you. Looking forward to next month's Sky Notes. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night missions on here. Now, I've got a bunch of little articles. I'll just skip through those real quickly. And unfortunately, there's no video or space weather report from Tamitha. It's been about 2 weeks now since her last report, so unfortunately there's nothing from Tamitha, but it doesn't matter. Okay, the first article, courtesy of astronomy.com. Yep, no worries, one. I just thought I'd throw this one in because it was there. How do radio telescopes work? So we do have a graphic for this, and I'll bring that up. Camera's a little out of focus on me. Where are we? Okay. So, how are images made from radio telescopes, you might ask yourself? Radio telescopes come in all shapes and sizes, depending mainly on the radio wavelengths that they are designed to receive. The most familiar sort is a curved dish that reflects radio waves to a focal point ranging from meter to sub-millimeter wavelengths. Usually, radio waves are reflected by a smaller secondary reflector back down to the center of the dish, where it is much more convenient to place feeds which convert the radio waves to electrical signals and receivers. If there were only one feed at the exact focal point, the telescope would only be sensitive to radio waves from one small patch of sky. Those diameter in degrees is roughly 57.3 times the observing wavelength divided by the diameter of the dish. Did you know that? I'll just repeat that again. If there were only one feed at the exact focal point, the telescope would only be sensitive to radio waves from one small patch of sky. Those diameter in degrees is roughly 57.3 times the observing wavelength divided by the diameter of the dish. This would be like a single pixel in an optical image. Imaging an extended object or surveying large swaths of the sky becomes excruciatingly time consuming, building up the image one pixel at a time. I think we know something of that. Fortunately, there is a region around the precise focal point where radio waves are still in reasonable good focus. A second feed and receiver just off axis can observe a patch of the sky adjacent to the first, and you will have 2 pixels. Clever electronics and engineering reduce distortions from being off axis. That region is only big enough to accommodate half a dozen or so separate feeds and receivers. But that is still an enormous increase in speed and sensitivity. Since about 1980, nearly all radio dishes incorporate systems similar to the one described above. Crowding the feeds together places more beams on the sky. But these are difficult to build because the feeds interact with each other. These are called phased focal plane arrays. The 100-meter Green Bank telescope at West Virginia has 7-beam system for surveying interstellar ammonia, and at a wavelength of 1.3 centimeters. It's a 16-beam system operating at 3 millimeter wavelength observes carbon monoxide and other molecules. Large multi-beam systems are installed on arrays in Australia and the Netherlands. So that's it in a nutshell. Thank you, astronomy.com, for that. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society Victoria. Yes, the radio astronomy system up at Heathcote, the Leon Mao Radio Observatory, is all about doing that, and hopefully within the next early next year things will start rocking and rolling with getting the hydrogen line receiver back up and running and the dish back up and running, because I know there's been a few issues there. So it's just a matter of time. All right, next article. Where are we? Hubble. Something about Hubble. Another one, courtesy of astronomy.com. Hubble reveals another super Earth where it's not enough to cook a pizza. Recent studies show that LTT 1445 AC may be approximately Earth-sized, making it a strong candidate for further study. And there's a graphic for that, but it's only an artist's impression or illustration, if anything. Let me see if I can bring up my little insert. No, hang on a sec. Bring that back. The camera's not on me. Let me just fix my secondary camera here. Okay, that'll do. And I've now lost my ID. Where's my ID gone? What's happened to my ID? Bring it back up. There it is. Now I've lost that. There we are. Just filling vMix. Everything is done within vMix on this. So there's lots of clicking involved in getting things right. And I could bring up my little rotating box there. I did bring that up. There it is. Look at that. Isn't that cool? Okay, back to this. In 2022, NASA's Transiting Exoplanet Survey satellite TESS detected a planet orbiting a red dwarf star located 22 light-years away in Eridanus. When the planet designated LTT 1445AC was discovered, scientists could not initially determine its mass. But recent studies indicate that the planet may be approximately Earth-sized, making it a prime candidate for further study by the James Webb Space Telescope and other instruments. The current understanding is that the curious exoplanet has a mass about 1.5 times that of Earth and a diameter about 1.1 times that of our planet, making it a so-called super-Earth, as planetary scientists categorize them. Astronomers studying exoplanets, planets orbiting stars other than our Sun, employ a variety of methods to determine a planet's location and some basic data, such as its size, density, orbital period, and so on. A common method used to detect exoplanets is called the transit method, and this involves detecting the minuscule dip in light which we receive from a planet's host star when that planet passes in front of it. Think of how waving your hand back and forth in front of a flashlight reduces the shine across the room, but on a much different scale. Even massive planets are tiny next to their stars, and at a distance of light years, the resolution required to detect that dip in light is enormous, but it can be done. As such, a truly powerful instrument is required, which is where TESS comes in. This space telescope, launched in 2018, is designed to detect transiting planets, hence the name, and to study their characteristics. But if an extraordinary system is not aligned well, so that we can see transits, data will be hard to collect. This was thought to be the case with LTT 1445AC, where TESS recorded what scientists call a grazing transit. Emily Pass, an astronomer at the Center of Astrophysics at Harvard University, said there was a chance that this system has an unlikely geometry, and if that was the case, we would measure the right size. A planet's mass and approximate size can be deduced with the transit method by taking the mass of its star and determining how much light the planet blocks, along with its orbital period. But without well-defined orbital characteristics, it's pretty much impossible. Realizing the limitations with the TESS data, Pass and her collaborators turned to other instrument, the Hubble Space Telescope. They used Hubble to make high-resolution observations that helped to determine the planet's orbit was not a grazing transit. This allowed a much more accurate calculation of the planet's diameter, and this also allowed the team to calculate the planet's diameter at approximately 1.1 times that of Earth. Because LTT 1445AC orbits so close to its M-dwarf star, its surface temperature is likely around 260 degrees C, making it as hot as a pizza oven. LTT 1445AC offers an interesting target for future studies. Transiting planets are exciting since we can characterize their atmospheres with spectroscopy, says Pass. We are looking forward to follow up on observations that will allow us to better understand the diversity of planets around other stars. Yes, I find that rather interesting that we can actually measure those little dips in light, and I am so keen to do some of those little experiments in my own observatory. I've got a couple of telescopes there that should do the job pretty well, so I am so looking forward to doing that exoplanet searching, or whatever. Yeah, it'd be interesting to see if I can detect that here in good old Narre South. At 10:39, let's go on to the next article, and this has got a graphic with it as well. Let me see if I can bring that up quickly. All right, where's me? There I am. Okay. The James Webb Space Telescope detects methane in atmosphere of a scorching hot WASP 80b, another exoplanet. Finding methane in the atmosphere provides good roadmap for how to do it for planets more conducive to life. The James Webb Space Telescope has just detected methane in the atmosphere of exoplanet WASP 80b, and it has both little and everything to do with how we might someday find life in the cosmos. In research published November 22 in Nature, a NASA team reported the detection of methane in the atmosphere of WASP 80b. The planet is as inhospitable as they come, about half the mass of Jupiter and roughly its size, but orbiting its star, which is smaller than our Sun, in just 3 days. The world's average temperature is some 1,000 degrees Fahrenheit or 552 degrees Celsius. It's not the hottest known planet by any stretch, but that's not a comfortable temperature for any living cell, which is to say that none of the methane in its atmosphere was produced by life. The science on that is pretty confident, given that all our giant planets have methane too. Their solar radiation reacting with carbon and hydrogen in the presence of oxygen creates methane, CH4, which is relatively stable in the conditions found in these planets' thick atmospheres. So on Earth, this isn't the case. Methane tends to be destabilized very quickly in our atmosphere. So any present is mostly produced by living things, and this is why astronomers want to use it as a biosignature of sign of life when looking for habitable planets around other stars. But WASP 80b is nothing like Earth, and natural forces produced its methane. Natural forces produced its methane. So, why is the find important? ? Well, because spotting methane in exoplanets' atmospheres is challenging and hasn't been done many times before. So, finding methane in the atmosphere of any exoplanet shows we can find it at all, and provides a good roadmap for how to do it. It also allows researchers to use this elusive molecule to study how planets form and evolve. Now we will really be able to see where do methane and all these other important molecules form in planetary atmospheres, and how do planets compare with each other, says study first author Taylor Bell, a postdoc at Bay Area Environmental Research Institute. So, yes, discovering methane, very interesting. Let's go on to this next article. We have No, that one. Our universe's most extreme stars sometime glitch, and we may now know why, courtesy of space.com. And there's a little graphic for this one too, which I'll bring up there. And there's me. Of course, what you're seeing on the screen there is just an illustration that shows a neutron star glitching, if you could have told that, to release a burst of radio wave radiation. Published a day ago, space.com. Our research establishes a strong link between quantum mechanics and astrophysics and provides a new perspective on the inner nature of neutron stars. Scientists may finally understand the dynamics of neutron star glitches that occur when these ultra-dense dead stars suddenly speed up their spins. It would appear that the strange behaviour may be caused when tiny vortices of swirling inner material break the surface of these intense stellar corpses. The new breakthrough in understanding neutron star behaviour increasingly comes from a unified team of astrophysicists and quantum physicists who typically study interactions that govern the subatomic world, studying an exotic form of matter here on Earth. A better understanding of a neutron star glitches could reveal more about the inner composition and movements, thus giving scientists a window into an object that's made of arguably the universe's most unique and strange form of matter. Neutron stars, in essence, are made almost exclusively of neutrons, which is why they are so utterly dense. Our research establishes a strong link between quantum mechanics and astrophysics and provides a new perspective on the inner nature of neutron stars. Research lead author and Innsbruck University researcher Elena Polly said in a statement. There's only two more paragraphs, so I might as well continue on with that. Bringing neutron stars down to Earth. Neutron stars are formed when massive stars die, and their stellar cores, with masses between 1 and 2 times that of our Sun, collapse to a width of just 20 kilometres. And that's an absolutely huge reduction in size. The neutron-rich matter that comprises neutron stars is so dense that a mere sugar cube of it would weigh about 1 billion tonnes on Earth, about 150 times the weight of the Great Pyramid of Giza. As if we've ever weighed that. That extreme weight, along with the immense distance of these stellar corpses, means that we can hardly bring neutron star samples down to Earth to study. However, a multidisciplinary team was able to indeed bring the study of neutron stars down to Earth by numerically simulating a neutron star using a proxy in the form of an ultra-cold dipole atoms. An exotic phase of magnetic gases with a negatively charged atom coupled to a positively charged atom over a long distance. Wow, gets nice and technical, doesn't it? Well, actually, there's a little bit more to this article, just realised. The glitching of neutron stars may suggest that the matter beneath these objects' surfaces exists in the form of a superfluid, a substance that resembles a liquid but has zero viscosity. A measure of resistance a fluid has to, that is to say, a measure of the resistance a fluid has to changes in shape or to the flowing around. High viscosity fluids such as honey or cold maple syrup flow slowly and can even act like solids. Think stiff peanut butter or even glass. Stiff peanut butter. I don't think I've ever seen stiff peanut butter, but there it is. Anyway, think still peanut butter and even glass. Low viscosity fluids, on the other hand, flow more rapidly. But zero viscosity superfluids are another story. They rotate in the form of numerous tiny swirling vortices, all of which carry a little bit of the system's angular momentum. A key factor in this behavior, and thus a vital element of neutron star glitching, would be a state that shows both crystalline and superfluid properties, a so-called super solid. If neutron star demonstrates this behavior as they rotate, often as fast as hundreds of times per second, glitches would occur at vortices breakout of the star's inner crust, the superfluid, so to its solid crystalline outer crust. Those flyaway vortices would carry with them angular momentum that boosts the rotational speed of the star's outer layer. I see. This super solid phase has been induced in ultra-cold dipolar atoms of iridium, ER, and dysprosium, DY, by a group led by Francisca Ferlino at the University of Innsbruck, also an author of this work. The team found that glitches can indeed occur in ultra-cold supersolids, which are analogous to larger, more extreme glitching demonstrated by neutron stars. And these results suggest that it is truly, that is to say, yes, no, that says truly, these results suggest that it is truly superfluid vortices carrying angular momentum to the surface of these stars, and that make them appear to glitch. So finally, the approach developed by the multidisciplinary team will now be explored further by investigating the glitch mechanism in more detail, as well as how it might depend on the quality of the super solid material. The study could also help pioneer a new way to investigate stellar remnants like neutron stars in the lab for other purposes. This research shows a new approach to gain insights into the behavior of neutron stars and opens new avenues for quantum simulation of stellar objects from low Earth laboratories. Struth. Alright, well that was courtesy of space.com and about the odd neutron star that likes to glitch, like our Vela pulsar, which regularly glitches every 4 years. I think there's a bit of a funny glitch thing that occurs. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, and trying to bring up my next article, almost coming up to 10 o'clock. And yes, all right, we'll continue on with this one. Let me see. All right, I'll get rid of me there. All right. An extragalactic intruder may lurk among stars orbiting the Milky Way's black hole, published 24 hours ago. Courtesy of, who is it? Space.com. The star SO6 appears to have travelled 50,000 light years from a now extinct galaxy to reach the supermassive black hole at the heart of our Milky Way. So you can see Sagittarius A there. This what you're actually seeing is a real image. It is looking towards the heart of our Milky Way. The heart of the Milky Way is seen by the Subaru telescope, showing the central supermassive black hole and the star SO6. Astronomers may have discovered an extragalactic intruder among stars that orbit the supermassive black hole at the heart of our solar system. Sagittarius A, or Sag A, Sagittarius A is surrounded by a bunch of stars that rapidly orbits, which have helped astronomers determine that the black hole has a mass of around 4.5 million times of the Sun. Yet, as useful as these stars are, their existence is somewhat mysterious. This is because the intense gravity of Sagittarius A should make the heart of the Milky Way an environment that is far too turbulent and violent to allow the formation of stars at all. This has led scientists to theorize that stars around Sagittarius A may have migrated to this region after being born somewhere else in the universe. And new findings from the international team of scientists at the University of Education researcher, so I was trying to avoid names here, has revealed some of these stars that may have had vastly longer journeys to Sagittarius A than previously suggested. In particular, the crew discovered that a star designated as SO-6 may be over 10 billion years old and could have originated 50,000 light years away from its current location. To deduce the true extragalactic origins of SO-6, the colleagues have studied the star for 8 years using the Subaru telescope, an 8.2 meter optical infrared telescope located near the summit of Minokia on the island of Hawaii, operated by the National Astronomical Observatory of Japan. This investigation revealed that the star seen just 0.3 arcseconds away from Sagittarius A has a chemical composition resembling stars found in a small satellite galaxies of the Milky Way, such as the Small Magellanic Cloud and the Sagittarius Dwarf Galaxy. Oh, there's another image here. Bring this one up. I think some of us have seen that. This one is an image of the supermassive black hole at the center of our Milky Way. It's a behemoth dubbed Sagittarius A, incredibly revealed by the Event Horizon Telescope on May 12, 2022. The team explained this chemical makeup by theorizing that SO-6 was born in a small Milky Way satellite galaxy, that our galaxy actually cannibalized it at some point in the last 10 billion years. And this would have led to the star journeying tens of thousands of light years to Sagittarius A, ultimately spiraling around our galaxy's black hole rather than taking a direct path to the center of the Milky Way. If all this is true, it would make SO-6 the first intergalactic star discovered near Sagittarius A. However, many questions will remain about this star's existence and the story of all other stars living on the edge of a supermassive black hole. Did SO-2 really originate outside the Milky Way galaxy? Does it have any companions, or did it travel alone? With further investigation, we hope to unravel the mysteries of stars near the supermassive black hole. The team's research was published on December 1, Proceedings of Japan Academy, Series B. So there it goes. Just love the research that these guys are doing. Alright, you're tuned to ASV Radio, VK3EKH. And here is another interesting little story. Only goes for I probably won't read it all out. But it's to do with the Chandrayaan-3 Indian probe. And there's a kind of a 3D image of this here. Let's bring just that up. So if you've got any 3D glasses, here's your time to put on 3D glasses. There it is. For those watching TV. India returns Chandrayaan-3 moon mission propulsion module to Earth orbit. One published a day ago. The mission's objectives of Chandrayaan-3 have been completely met. The spacecraft that ferried India's Chandrayaan-3 lander rover duo to the moon has returned home, sort of. In a surprise announcement on Monday the 4th of December, the Indian Space Research Organisation, ISRO, said it had moved Chandrayaan-3's propulsion module out of the lunar orbit and placed it high above Earth for a bonus mission, where it now survives on leftover fuel. The new experiment will demonstrate technologies that will help Indian scientists bring samples from the moon to the Earth someday. The propulsion module, a box-shaped component of Chandrayaan-3 spacecraft powered by solar cells, now circles Earth every 2 weeks. ISRO has not revealed what it plans to do with the spacecraft when it runs out of fuel. On November 22, the module reached its closest point to Earth, coming within 95,000 miles, or 154,000 kilometres of the planet's surface. That was still high enough, however, to be safely away from other satellites. As per current orbit prediction, there is no threat of close approach with any operational Earth orbiting satellites. Earlier this year, the propulsion module completed its main task when it placed Chandrayaan-3's robotic lander and rover in a tight orbit around the moon prior to their historic landing near the South Pole in August. The module then moved to a slightly higher orbit around the moon for a science experiment studying our planet to assist with the search for Earth-like exoplanets. Lovely and short, that's how I like them. Okay, and finally, yes. James Webb Space Telescope again, and there's a picture here. Let me bring this up. This is a nice image. This is one that Eddie should go for. G'day to Eddie if you're listening in the background there. The James Webb Space Telescope finds Earth-like planets can form in harsh galactic environments. Despite being blasted by molecule-destroying ultraviolet radiation, at least one planet-forming disk in the Lobster Nebula has the building blocks of rocky planets. Have any of you astrophotographers out there photographed this one? I don't think I've seen it yet. Do it this weekend. Lobster Nebula. Go looking for it tomorrow night, guys. I want to see it on Facebook. There's a task for you, Eddie. The Lobster Nebula, also known as NGC 6357, is teeming with massive stars that have carved and sculptured the nebula's wisps of gas and dust, located around 5,500 light years from Earth in the constellation Scorpius. The nebula is one of the youngest and the closest massive star-forming regions. It famously contains some of the most massive stars in the Milky Way galaxy, nestled within a cluster dubbed Pismis 24. P-I-S-M-I-S. Pismis 24. New observations from the James Webb Space Telescope focus on one of Pismis's 24 residents, a young sun-like star swathed in a dusty protoplanetary disk from which planets may eventually form. This particular star sits near a pair of massive bright stars that blast the region with ultraviolet radiation, a common occurrence in massive clusters. The work was published in November 30 Astrophysical Journal Letters. It is the first time the effects of external radiation on protoplanetary disk has been studied in massive star-forming regions. Despite the punishing and chaotic environment, researchers found that the inner regions of this particular disk, dubbed XUE1, don't seem that different from the disks around stars in calmer, low-mass star-forming regions. The similarity indicates that rocky planets can form even in challenging surroundings. The find can now give further clues into the types of environments in which rocky planets can form. and there's just an artist's impression here. Where is it? 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 I didn't move it across. There's always one image I forget or don't move across. Oh, I think I see. Okay, there's two of them. Oh, I won't worry about it. It's getting on. It was just an artist's representation of a star surrounded by a protoplanetary disk. But I think we've seen a few of those in the real ones taken by the Atacama Desert Observatory. All right, let's just go straight to spaceweather.com. What's happening with spaceweather.com? All right, let's put up the current disk of the sun. There it is. If the sun was in the sky right now, this is how it would look. Nice and round and bright. The solar wind is currently at 444.6 kilometers a second at a density of 7.1 protons per cubic centimeter. There are currently 1, 2, 3, 4, 5, 6 or more sunspots on the sun. I can't really tell because there's overlapping numbers there. Yeah. Let me see if I can take another look at that. No, I can't do that. Oh, yeah, I can. Yeah, I can. 1, 2, 3, 4, 5, 6, 7, 8. 8 sunspots. 8 designated sunspots on the sun at the moment. So the current sunspot number is 121. The radio sun, the radio flux, is currently sitting at 135 solar flux units, measured at a wavelength of 10.7 centimeters. The aurora australis is completely unlike how it was last week, but this is what the current glow over Antarctica looks like. So see how very different it is tonight. Last week it was so much more intense, and there was plenty of aurora to be seen and photographed, but not tonight. And coronal holes. Oops. There's not much in the way of coronal hole activity. There it is. This current view of the sun. There are no significant coronal holes on the Earth side of the sun, so that's how it's looking at the moment. Okay, the planetary K index. Currently, the KP index is equal to 1.33, which is considered quiet. The 24-hour max KP figure is 2.33, also considered quiet. Now, there is a CME. A CME is heading for Mars, so we don't probably have to worry about it. Earlier today, a full halo CME left the sun, and analysts believe it will miss Earth. Instead, it is heading for Mars. NASA models suggest a direct hit on December 11. The impact will probably spark ultraviolet auroras and erode a small amount of the red planet's atmosphere. And of course, the other thing that occurred just recently was an extremely rare occultation of Betelgeuse. And do I have that image here? What have I got here? This one. Let's see. Let me just bring this up. Okay, so for years astronomers have worried about that Betelgeuse might explode. Next week, it's going to disappear instead. On December 12, Universal Time, a main belt asteroid, Leona, will pass directly in front of Betelgeuse at a magnitude star in the shoulder of Orion. Millions of people in a narrow path stretching from South Florida to Europe can look up and see Betelgeuse's dim or even vanish. Unfortunately, we're not going to see too much of it here in the southern hemisphere, but hopefully astronomers will get a really good view of this observation of this particular event, and we'll get some more information on it. What you're seeing on the screen there at the moment is images of Betelgeuse taken by the European Southern Observatory's very large telescope, and the various varying changes that Betelgeuse it seems to generate over time. All right, enough of that. What's next? I think that's about it, really. Yep, that's about all I've got there. So, potentially hazardous asteroids. As of the 8th of December, there were 2,349 potentially hazardous asteroids. Potentially hazardous asteroids, but none of them are on a collision course with Earth at the moment, of course. So I think that's about it from a summary of spaceweather.com as we speak. So on that note, we shall conclude tonight's broadcast. I hope you might have gained some interest out of some of those articles, from Tanya Hill's Sky Notes to how a radio telescope works, to Hubble revealing another super Earth, and how James Webb Space Telescope detects methane in the atmosphere of a hot wasp, to our universe's most extreme stars that sometimes glitch, to an extra galactic intruder that may lurk among Sagittarius A at our Milky Way centre, to the Chandrayaan 3's mission, Indian probe, sitting there on the surface of the moon, and to NGC 6357. That's a beautiful object, NGC 6357, the Lobster Nebula. I don't think I've heard that one before. Let me bring it up again. Come on, there it is. Yeah, isn't that a stunning object to photograph? I'm looking forward to seeing if I can do that at some point in the future. Sometime, maybe. There was something else I was going to show there too. I noticed in my thing. Oh yeah, okay. Oh, I shan't worry about it. Oh, I'm losing my voice already. Okay, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast on the 8th of December, concluding tonight's transmission. And before we do disappear, we shall take a quick call back on 80 metres to see if any stations wish to call in. We haven't had too many people join in on the chat window tonight. It's been very, very small there. Only the 4 people that I called out before. And we have Andrew, VK3KIS, that's called in, listening on 80 metres. A little bit noisy this evening, but basically 5 and 8 in Ringwood. Thanks, Andrew. Not a problem. All right. Let me call on the frequency and see if there's any stations wishing to check in. This is VK3 EKH listening on 3541. Okay, VK7JAH, VK3TJS, and VK3SBX. Anybody else? VK5 Whiskey Alpha. Any other stations? All right. To the top of the list. G'day, Martin. Hope the signal down into Tasmania was good tonight. VK7JAH, VK3EKH.
trees up there. Good God, I can't remember how many the catalogue is about 30,000 objects. So anything's possible, but certainly it's totally short of objects. I'm not sure what's like likely to come out of that. Nevertheless, not too bad. Solar activity looks good. Not enough for the war down here. Unfortunately, last Friday night when it was spectacular, it was 100% cloud down here. The cloud that looks like that it might have been glowing through the clouds a little bit, but I think that was just opposite of that night. But tonight you can't see anything from the rain over clouds, so it's very ordinary out there. And I think the signals are good tonight. Yeah, really the usual 30 to 30 over line.
Yeah, thanks, Martin. VK7JAH, VK3 EKH returning. Very good. Yeah, thanks, Martin. Yeah, lots of lightning static on the band tonight, but you managed to get through mostly. So yes, I think there were plenty of good photographs taken of the aurora last week, and from New Zealand across to Western Australia, I think, and there were plenty of locations where fortunately the sky was reasonably clear. So yeah, some absolutely beautiful images. It's just unfortunate that just a couple of locations there, the cloud were a bit of a problem. The cloud is definitely an issue for all optical astronomers one way or another. But yes, certainly last weekend it was firing, and there's more to come of that, with the solar cycle still to peak, cycle 25. There's definitely going to be more auroral chance of seeing it. I've yet to see it myself, so there's a good chance of seeing it still. Anyway, thanks, Martin, for calling in. It's good to have you at the top of the list. And thanks for the report too on the YouTube stream. It's held in there. It hasn't fallen over or anything like that. Not yet, at least. Anyway. Thanks, Martin. Across to you there, Jack. VK3TJS in Shepparton. VK3EKH.
VK3TJS. I suppose the group heard from. So in the broadcast, of course, good evening to Glenn, good evening to everyone that's joined in that, and yeah, pretty good net out of them in triples, which we kind of pleasant to listen, but yeah, nevertheless, very interesting subject, and thank you very much for running the net, and hope you have a good weekend, and see that aurora live, I think. Yeah, I mentioned yes in this photo, but yeah, seeing it live is probably a good experience. So thanks a lot again, and I'll catch everybody next time. VK3KH and VK3TJS.
Yeah, thanks, Jack. VK3TJS, VK3EKH. Very good. Your good signal here, hovering around 20 over 9, so not a problem copying you. And thanks for the report. And yes, once again, well, you know. If I had been really keen, I would have taken off in the car and gone down the coast somewhere to try and have a view of this aurora. But oh well, yeah, we'll get around to it, Jack. We'll eventually see it one day for sure. Before I leave this earth. Thanks, Jack. Steve, VK3SPX, VK3EKH.
Astrophotographers just near us here in Baringup, a bit closer to Malden actually, got some great photos of the aurora in between some clouds at about 11 p.m. just about the time you were starting the callback last week, but I went out, I didn't see anything, it was just wall-to-wall clouds, but you don't need to be on the coast because it was kind of fairly high in the sky and pretty obvious, so yeah, anyway, I still haven't seen one, maybe one day I will, but I had a look through the Facebook astrophotography page of someone photograph of the Lobster Nebula
but I couldn't find one. I dare say someone got it once or twice, but I couldn't see it. I have done the cat's paw, which is very close to that one, which is quite a spectacular thing. I was intrigued about the SO6 star. I felt a bit sorry for SO6, like how would you feel? You travel for 10 billion years, 50,000 light years only to probably wind up being swallowed by a black hole. There's a long way to go to oblivion. I have to say there's any planets orbiting around us. Well, who knows? Maybe there is. Anyway, yes, no worries, Liz. Good stuff. Well, we'll see you next week. VK3EKH, VK3SPX.
Good on you, Steve. VK3SPX, VK3EKH. I tell you, almost every week astronomers are finding new things about the universe and the way things go, the way things work. And part of my job here is to try and bring those little news items every Friday. I usually spend about an hour to finding very quickly these articles that potentially would be an interesting read. And it always intrigues me how every week there are something new being discovered. We've got so many interesting observatories out there, whether it's radio telescopes or infrared telescopes or just normal optical telescopes, the Hubble and the James Webb, all these amazing observatories. Every week they're managing to capture something new, and of course we've got these amazing astronomers that are just so keen, that focus on one task to find out all this information. It's God bless them. I would love to be, I'd love to have the smarts to be able to be on the team of one of these groups that are doing specific research, and to study this SO6 object. I don't know. It takes years. It takes years to study this stuff, and it's just amazing that we've got the capability of being able to have this fine resolution on the sky. So it's really it is impressive stuff where we are at the moment. We are. What's the term that Carl Sagan uses? We are something for the cosmos to know itself. What's the term he uses? We are something for the cosmos to know itself. Basically, he's just saying that we are at a point in time where we have the capability of understanding the universe and learning about it. To know itself. I can hear it in my mind, but I can't remember quite clearly what he says, how he says it. Doesn't matter. Anyway, look, we'll get around to seeing the aurora one day, and even if it means, if as soon as I get an idea that there's going to be something happening, I'll just get out in the car right now and just go straight down to a top of a hill somewhere in a dark location and see if I can see it. Have a camera with me. Thanks, Steve. No news on the dome at this stage. It's I still haven't got any feedback yet on a possible assembly date, installation date. So we're just waiting for the time to occur on that one. But we'll certainly let you know when it happens. Thanks, Steve. Across to Dallas. I hope I can copy you there, Dallas. You weren't terribly strong, but there's a lot of lightning crashes going on too. VK5WA, VK3EKH.
Yeah, I hope you can hear it much better. And
Yes, VK5 Whiskey Alpha, VK3 EKH. Okay, Del, it's a bit tricky to hear you overall. My noise level's right on S9, and you're kind of hovering just about there. So it's just a little bit tricky to copy all that, but certainly heard the comment about the aurora as well. And this, spaceweather.com, if you can, unless you've got a website that you can go to that keeps you informed about a possible aurora. I certainly get all my information from just that one site, spaceweather.com, and they have the little link there to Antarctica, the view over Antarctica, and you can see how the aurora oval over Antarctica is progressing as the sun moves around. And again, last week it was just so intense towards the mainland, but at the moment it's not much happening at all. So just keeping a sign, keeping an eye on those sorts of sites, certainly give you an idea of how things are going and whether to head outdoors to see if you can see it. There was an email list. I did subscribe to an email list that I thought would send email straight away as soon as there was a auroral activity, but it only really sent you emails after the fact. It's like it was a reporting type thing. So if someone had seen an aurora, you send information saying, yep, we reported seeing an aurora at such and such a time and whatever, and of course this email would go out hours later, so it was never really good enough to get you out there straight away. So but there are other sites, like I say, the spaceweather.com site is the one that has the link to the map over the Antarctica. Anyway, that's fair enough. Okay, thanks, Dallas. Pity your signal wasn't just a little bit stronger there, but anyway. Is there any other stations wishing to check in before we disappear? VK3 EKH? Yes, there he is. Okay, go ahead, Ian. VK5 Kilo Tango, VK3 EKH. Thanks, Ian. VK5 KK2, VK3 EKH returning. Very good. Yeah, just a little bit stronger than Dallas, just a bit stronger, and a little bit easier to copy as well. But thanks for calling in, and much appreciate you. Definitely down in the log book, as they say. All right, if there's nobody else, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast. Information about this society can be found on the website at www.asv.org.au. We'll be back next week to do it again. We're aiming to finish up the last broadcast will be the 22nd of December. Yep, that's a Friday. So just before Christmas. So I'll do a last cast then, and then the plan is to sort of take 4 weeks off, I think. Yeah, I go back to work on the 15th, so I'll probably make the first broadcast in that week to come back. I do plan to do a bit of mucking around with the studio here, so I'll be effectively off air anyway for a little while I get things sorted out. Anyway, we'll make that little announcement on the 22nd as well. This is VK3EKH with VK3CSJ on the microphone, bidding everybody a very pleasant weekend. It's going to be a very strange one weather-wise. To everybody up at the Starbq, up at Heathcote tomorrow, I hope you have a good time. I hope the weather plays nice, and but have a good time and look through all those wonderful telescopes that'll be set up for you to look through. It should be a good night, hopefully. This is VK3EKH closing down on 3541 kilohertz. Cheers, everyone. Take care.
Before you go, Clint, VK3 Delta X-ray.
Yes, go ahead, Greg.
Good evening there, Clint, and thanks for the broadcast, mate. I thought I had to get in. I thought I was going to miss out. Signals 5 by 9 plus about 20 to 30 there, Clint. 30 signal. You mentioned the great southern lights. Like you, I've never seen them, mate, and I probably live in a maybe better location, not far from the coast. But I'm never there when it's happening. So there you go, mate. You good on your Clint, and you certainly deserve that break, mate. You've done a great job throughout the year, so I think you mentioned it next week, but anyway. One over, Clint, won't keep you. You go and have a coffee or whatever you go and do, mate. And thanks for taking my call. VK3EKH. VK3 Delta X-ray. Greg and Laudable. Cheers to all the listeners out there.
Yeah, signal 10:15 over 9, loud and clear, so not a problem at all. And I'm not sure if there was another station there too. I pressed the PTT just as I think I heard somebody else. I'm not too sure. Was there somebody else?
VK3CSJ, VK3SPX, yeah, it was me, Clint. Yeah, look, I just going to say, I looked up your quote, and what he said was, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. So that was it, VK3CSJ, VK3SPX.
That's it. That's what I couldn't remember. There was so much more to it. I knew the last part of it. We were the way for the universe to know itself. It's so profound, and I couldn't quite remember the rest of it. Yeah, Carl Sagan was an amazing man. He was full of interesting quotes like that. He should still be with us, and I've got a copy of Cosmos on Blu-ray. I bought that little box set a while ago, and I've yet to put it on to watch. So I might do that. I might have a binge watch of Cosmos over the Christmas break as well, and absorb myself into his Cosmos series. Never ages. You know, what's his name? Tyson, Mr. Tyson. He's also taken on the modern version of Cosmos too. I've managed to watch a bit of that. I didn't go all the way through, but I still enjoyed anyway some of the episodes that he had on a modern Cosmos series. Tyson. Can't think of the rest of his name. It's just mental lapse. Anyway, no worries. Thanks, Steve. That was a good one. Thank you for doing that.
Yeah, no worries, Clint. VK3SPX clear.
All right. So we shall also finish here on YouTube and the TV repeater. So again, anybody who's still watching up there at Heathcote, have a good day tomorrow. I don't know if anybody's. There's been no email from anybody up there. No. So I just check the mobile phone to see if there's any messages here. No, okay, all right. Well, I just have to assume that nobody watched up at Heathcote tonight. Doesn't matter. It's they're all probably getting an early night for those that have decided to travel all the way up there to spend the Friday night and get ready for a good show tomorrow night. Okay, this is ASV Radio closing down the YouTube stream. Thank you for watching, everybody. Where is my mouse? There it is. And I do appreciate your patronage, as such, as they say. Patronage. That's the word. Anyway, all right. Cross to some colour bars, and I think I'll finish on that note. So, everybody, take care. Have a nice weekend. I'll be back Sunday morning with the WIA broadcast at 10:30. Oh, not to mention at 9 o'clock on 160 metres AM. And then an hour later will be the 10:30 TV broadcast, and then repeated at 8 o'clock Sunday night. So this is VK3 EKH with VK3 CSJ on the microphone. Yep, will disappear. All right. Cheers, everyone. Take care.